Okay, YouTube, in this video we're going to continue to explore operations with matrices, and in this video we're going to focus specifically on scalar multiplication. So when we talk about scalar multiplication, really what it is multiplication of a matrix by some real number. And you can see like an example of this here. We see this 2 by 2 matrix and a 4, which is just some real number out in front, but we're going to refer to this real number as a scalar. And the concept of scalar multiplication is a pretty simple one in that it's just kind of like distribution. It acts as it would with real numbers in front of a set of parentheses with some sum or difference there. We could distribute this through this matrix quantity, and you can see that really all we're doing is really scaling up our values by a factor of 4. So in terms of scalar, I'm actually not sure why they call it a scalar, but I always think of it in terms of this number that we're multiplying by here that's not equal to 0 is scaling up our values or scaling them down. So we say that a matrix of order 1 by 1, such as just 6 here, contains only one entry. So it says to distinguish this matrix from the number 6, we refer to 6 as a scalar. So you can see the difference here in the two notations. This is a different thing than this is. We say a matrix is a matrix. A scalar is a real number. So let's make a note here. A scalar is simply just a real number by which we multiply. By which we multiply. And so we're going to scale things up and scale things down. They're scalar multiples. So essentially, to multiply a matrix A by a scalar C, we multiply each entry in A by C. And this is our example here, but you can see that the definition down here includes A as being this matrix full of all these little A's in the ith row and jth column. So with all those little A's, if this is some matrix of order n by n and C is some real number here, some scalar, then the matrix C times A is the n by n matrix, so it has the same order as the original matrix here, but just that all the entries on the inside have just been multiplied by this real number C. And well, I suppose we could multiply by 0, but we often don't do that. So we say that CA is a scalar multiple of A, and essentially one thing that we want to make sure that we note is this. A scalar multiple is a matrix. So you get a matrix product of a scalar multiplication. So as we look at this example here, we could say if A is equal to this 2 by 2 matrix here and B is this 2 by 2 matrix here, what we want to do is evaluate these matrix expressions. And so to evaluate this, my number one piece of advice would be at first to just go ahead and rewrite the matrix B. I guess here's our expression, negative 5B, but we'd say this is the same thing as negative 5 times the matrix B, which is this 2 by 2 matrix that has 2, negative 3, 5, negative 6. So with this here, essentially what we're going to do is just multiply all of our entries by a negative 5. So all of our entries are going to become opposite signs, and they're going to be scaled up by a factor of 5. So we get a negative 10 here. Let me try to rewrite that there. Negative 10, I suppose we get a positive 15 here. We get a negative 25 here. And last but not least, we get a positive 30 here. And so with our next expression, you can see that we have 2a plus 3b. So we have a couple of products here, scalar multiples that is, and then we have a sum. So just like you do with order of operations, we kind of have to do our scalar multiplication first, and then we're going to add those scalar multiples together. So in this case, we have 2 times a, which is this 2 by 2, negative 1, 4, 3, 0. And this is plus 3 times b, and our b matrix here is that 2, negative 3, 5, negative 6. And so what we end up with is this new set of matrices that we can add together after we scale and multiply. And in order to get our answer here, we'd have to have another 2 by 2. So let's just go ahead and fill these out. We'll evaluate. So we'd say doubling all of these, we would get a negative 2, 8, 6, and 0. And if we triple all of these values here, we get a 6, negative 9, we would get a 15, and a negative 18. So pretty simple. Now we'll just go ahead and finish by adding these together. And adding two matrices, remember if they have the same orders, we'll just add these corresponding entries together to get our new entry. So first row, first column, entries. Negative 2 plus 6 is a 4. We get an 8 plus a negative 9 is a negative 1. 6 plus is 15 here, give us 21. And then, of course, 0 plus negative 18 is negative 18. So go ahead and give this a shot down here. And yeah, that's how you scale and multiply. Cheers.